Okay, Assalamu alaikum warahmatullahi wabarakatuh. So today we are going to start the new lesson, right? We have completed up to, yes, 3 lessons that is basically based on the general chemistry. Now you are going to step into what the physical chemistry. I already given, right? I think here recording means you can talk, you can ask question, so whatever it is, and any other question, any other non-related subject stuffs, if you want to speak, let me to know. I'll pause the recording and we will speak, right? Okay, so here I already told you about the physical chemistry, right? So the grade 12 is based on the physical chemistry is unit 4 and 5. So now we have start the unit 4, gaseous state of matter. So from the heading, simply you can understand, we are going to talk about the matter which is based on the gases. So the first of all, this is the introduction of what the organization of particles in three principal states and their typical characteristics. Simply, we are just going to speak what is meant by matter and how we are going to deviate the gaseous state of the matter, right? So this is not new for you. Right. So when you speak about the organization of the particles, right? So three principal states. So can you say what is the three principal states of when you consider a matter? Can you say just for the idea? We talked about this earlier. Yes.
Solid, liquid, and gas.
Of course. So according to keeping the matter, we are just going to speak about the solid, liquid, and solid gas. So, right. Okay. What is mean by matter? Simply, anything occupies the space. It should have a mass that called matter. So according to that only, we are going to categorize these matter can be classified into solid, liquid, and gas. Definitely, this unit is based only the gas. Before start the gas, we are just this presentation just going to focus only about these three states. What is their physical characteristics? That's all. Okay. So when you speak about the states, right? Okay, there is the possibility the matter can be converted into one state to another state, right? Okay, this is what we are calling is interconversion between one matter to another matter, one state to another state, right? Definitely you know what is I'm meaning, right? When you check the solid, yes, the solid able to convert into what? Liquid. This state we are calling what? Interconversion. Did you understand? Did you understand? So
Yes,
simply,
ma'am.
yes, simply when you take the example, right? The solid means the universal stuff. We'll take the water. Water is always appeared in the solid is ice cubes, right? So when it start to melt, or if you given the heat or somewhat, when it start to melt, definitely it will convert into what? Liquid. If you provide more heat, more temperature, it will convert into what? The vapor of steam. That is what the gaseous state. So these each steps we are telling what the interconversion between the three states. Did you understand?
Yes,
Yes.
madam.
Yes. And this is, I said, the forward reaction, forward process, and you have able to backward too, right? When you compress the steam, you can make it as a liquid, right? Cool down, right? Again, what the solidification, it's go for the solid. So this is what, let's say start to speak about the solid, liquid, gas, and their some physical characteristics, right? First, give me a second. Annotation. Yes, right. Okay. So look at here. This is what is solid. They have taken what the name. Okay. So simply we know the solid is what is the nature of the characteristic. They have a fixed shape and a fixed volume, right? Why is so is when you take the particles inside the solid is they are strongly bonded. Can you see it? Right? This is what they are telling is the solid has strong interparticle force. What is that? Interparticle force. Simply you can understand a kind of intermolecular forces like that. The between these particles, each particles, can you see? Give me a second. Yes. Yes. Look at there. Between these each particles, right? They have strong connections, right? Which is because of the strong intermolecular, right? Interparticle forces, they are maintaining the fixed shape and the fixed volume, right? Here, do you know the solid particles can be vibrated, they cannot move around, right? Did you understand? Why? They have strong interparticle force. Because of that, these particles will be vibrated, but they cannot move around. Is it clear? Is it clear?
Yes,
Actually,
madam.
you know these things. I just wanted to do, that's why. I don't want to run because I don't have a pen tablet or something like that. If it is too fast also, I don't want to do like that. That's why, right. And next, liquid. Definitely, you know about this. The liquid are, they don't have any fixed shape, right? Like your solid, but they have the fixed volume. Simply, they are not like your solid, but they have the moderate interparticle forces. The particles can be what? I forgot to say, atoms, molecules, or ions, right? Whatever. So they have the moderate. So that means what? Somewhat these particles can be moved. And some extent they move around. That's why the liquids are getting shape of your container. If you understand. Okay. And
Yes,
finally,
madam.
we are talking about the gas. Simply, the gas, they don't have fixed shape and the fixed volume. Very, very weak interparticle forces. Therefore, they can freely move. Can you see here this picture? Why have put it? The reason is you can see the solid are it's strongly, regularly arranged. Can you see? And it is having the strong intermolecular particles, sorry, interparticle, intermolecular, interatom, whatever it is. They have the interparticle strong attraction. That's why they have the fixed shape and the volume and staying like that. So when you take this, yes, they have the moderate amount. So therefore, they don't have this fixed shape. They're able to move here and there. But they have the fixed volume. That's why they are maintaining the moderate interparticle forces. But the gases, not like that. Yes, very weak intermolecular forces. These molecules will move here and there, and they don't have any friction, right? Okay, let's see more to them. Next one. Okay. I already said three states are matter differ from the arrangement and movement of particles we talk, right? Because of the interparticle distance, right? We have to speak about the another word called the interparticle distance. What they are meaning? Yes. Simply, they are talking about the same rules, the interparticle force, like that, the interparticle distance. When you have the strong interparticle force means what? Then we'll take the, what is that? Solid, right? So here, they will have what? Very strong attraction, right? So I'm using mouse, so it will be a little bit untidy. Please accept my apologies, right? Okay, so what is happening here? Because of the strong intermolecular forces, interparticle forces, their distance is what? Interparticle distance is low, right? Okay, so the solid is having the lowest one when you compare with the liquid, but the gas, they don't have the fixed amount, they don't have the fixed shape, they don't have the fixed volume. So what will be happen when you take a container, the gaseous molecule will move here and there, they never hold together, right? So this is what, from one molecule to another molecule, the intermolecular distance is high, right? Okay, so because of that, they are telling is the gaseous molecule having the interparticle distance is higher than your liquid and the solid. The solids is showing the lowest interparticle distance, right? So as a result, I already told you, the distance is, the force is when you take the gaseous molecules, there is no for very weak interparticle attraction. Therefore, the interparticle distance is high. Because of that, their randomness. You know what is mean by randomness, Azri?
That means they can feel in.
Sorry, I couldn't hear you well. They can?
They can feel.
So yeah, that means you are telling is they can move here and there without any, what to say, any control. That is, we are calling the randomness, right? When you speaks about the randomness between the solid, liquid, and gas, solid, there is no randomness. They can vibrate. Why? They are having the very strong intermolecular forces, right? Okay, interparticular forces, right? But when you take the volume, sorry, liquid, they have a kind of the randomness compared less than your gas. Why? The gas is, now only I told you, very weak interparticle forces, therefore their interparticle distance is high. As a result, their randomness of the molecules, ions, or atoms is high. They will move here and there around the container. So finally, right, the particles of the gas will move fast and free compared to the liquid state particles. Did you understand?
Yes, madam.
Right. Okay. Solid is having the limited vibration, right? Right. And seriously, I'm not going to say explain the word by word. The thing is, what is there? I just will tell my by my word. You know how I usually teach us, right? Okay. So this is the simple properties of what your solid, liquids, and gases. We already talked. Okay. Just have a look. What is there? This good. Okay. When you take the solid, we'll think about the shape, right? I already told you solid is having the definite shape because of what the interparticle forces, right? But the liquid is take up the shape of your container, but do not spread throughout the entire volume of the container. Why they are telling like that? Simply that is the reason the interparticle forces. They have the moderate interparticle forces, not like your gases, the weak interparticle forces. They will get the shape of the container, but not like your gases. It will move around all the places of the container. This is what they are mentioning. When you take the gaseous molecules, the shape of the gaseous molecule, definitely they will take up the shape of what the container, and it will occupy the entire volume of the container. This is the difference between the liquid and gases. Got the point? Clear?
Yes, madam.
Thank you. And next, volume of solid is definite. Yes. Liquid is definite, but your gaseous is occupies the volume of the container. So we are talking about what? When usually we speaks about the volume of gases, according to the container only, we will choose to speak, right? Okay. And next, density, right? The density of the solid is high. And you know why? I already told you, because of the heaviness, the molecules are very strongly attracted. So here they have the moderate high values, right? But when you go for the gases, they have low value of the density, right? And finally, this is very important, the compressibility. Solids, extremely hard to compress, right? You know, okay? They have fixed shape, high density, definite volume, so it's hard to compress. And same thing like your liquid, also hard to compress, but the gaseous is the very easiest molecule which is able to do the compression, right? Okay, let's move on to the next slide. If you have any doubt, pause me and ask the question. It doesn't matter, right? Okay,
Okay, madam.
thank you. All right, give me a second. Okay, right. You and me there. This session will be end within 40 minutes. Okay, right. Usually it's 2%. It won't finish. I don't know why it's asking like that. If it is finished within 10 minutes, Asri, please rejoin. Same ID, okay? Personal room, same password, right? Rejoin, okay? Yes.
Okay, madam.
I already told you the matter can change one state to another state, right? That is, we spoke about what interconversion, right? So how can you change? By increase the temperature, right? You can change the one state to another state. So how it's happening? When you increase the temperature of the system, right? Your state, your matter. What is happening? The particles, atoms, or ions, right? That will start to move faster. Therefore, their interparticle force will reduce. The interparticle distance will increase and it will lead to the change of the next state. Did you understand? This is what is happening when you use the solid material to liquid material. Actually, we told you the solid is having what very strong interparticle force. So by providing the temperature only, we are breaking that interparticle force and convert into the liquid. Why? Once you break the interparticle force, the distance will be what? Increase. Interparticle distance between the molecules will be increased. Then these molecules start to move very fastly and it will change one state to another state. That means the solid to liquid. Did you understand?
Yes, madam.
The same thing will happen from the opposite. Yes, when you decrease the temperature, what will happen? Liquid to solid. That we are telling is solidification, like your ice cubes, right? Simply, this graph is, this figure is well enough to understand what they are telling here, guys. The solid, when you provide the temperature, it becoming a liquid. That state we are telling what? Melting process. When you provide the more heat, right, the liquid will convert into the gases. That process we are calling what? The evaporation. You know these words, right? These words are very important. So when we are studying the unit 5, you need that and you already know. And just recalling. And second, the solid directly coming as a gas, we are calling sublimation. You know these things? These three statements, definitions, you know, right? Yes or no?
Yes, madam.
Yes, right. And next, opposite one, decreasing a temperature, right? When you decrease, the gas will become a liquid that we are calling liquefaction. And same thing, liquid become a solid, we are calling solidification. And simply, this is can be explained by the water molecule, right? So when you take the ice cube, just keeping outside also, if you provide the heat, means what? Keeping outside from the freezer. That means increasing the temperature, it will become as a water. Again, what we are telling is it should come the gas now. Definitely, you have to provide the high temperature up to 100 degrees Celsius. Then it will become as a steam that is called the gas. And again, we are using the liquefaction, that is a process of the condenser. And from that, you're getting the liquid. And again, the liquid just keeping inside the fridge, you can make a solid ice cubes. Did you understand? Is it clear?
Yes, madam.
Okay. Okay. Right. Yes. The interparticle forces tend to keep the particles together, but the thermal energy of the particles tend to keep them apart. So this is what they are telling is, I already told you, why we are providing the temperature to break down the interparticle force. So usually the interparticle force, what it will use to do is, it will keep your molecules together, but the thermal energy means what? Is somewhat you have the temperature, therefore because of the temperature, the thermal energy, the particles, right, will lose the interparticle forces and it will increase the interparticle distance, therefore these particles will keep them apart. Is it clear? And this is what?
Yes, madam.
Right? This is what they are speaking. When the intermolecular interactions are very weak, the molecules do not tend to make liquid or solid. Sorry, wait. Sorry, okay. When intermolecular interactions are very weak, molecules do not tend to make the liquid or solid unless the thermal energy is reduced by lowering the temperature. So this is, they are talking about what? Your gaseous molecules. It is having very, very weak interaction. Until now, I talked this somewhat like your strong interaction and the moderate interaction, right? But here, they have very weak interaction. So simply, if you want to say, get them to the backward stuff, right? What do you want to do? When from the gas to liquid, definitely you have to reduce the thermal energy. You have to reduce the temperature. Then only you can do the backward reaction. Because of what? It is have very weak interaction. Yes, I already said. The gases do not liquefy on compression only, although the molecules are very close to each other and intermolecular forces operate to the maximum, right? So therefore, what they are doing is the thermal energy of the molecule is reduced by lowering the temperature. Now you can easily liquefy. This behavior can be explained by the following figure, how this intermolecular forces happens, right? So here the intermolecular forces increasing forward, the gas to liquid, the liquid to solid. As it is, we know the gas is having very weak intermolecular forces, right? Compared to the liquid than your solid. So therefore, towards to that, you have to reduce the thermal energy. Then only you can compress easily from gas to liquid, liquid to solid. This is what the behavior of three states of the matter against the intermolecular forces and the thermal energy. Did you understand? Simply, this is you already known, right?
Yes, madam.
It's my responsibility according to your syllabus. I just wanted to teach. Right. Thank you very much. I have completed the first presentation. I have another half an hour, I think. Right. So almost here less than 1 minute. Leave the meeting and rejoin. Okay.
Okay, madam.